The Apollo Passive Seismic Experiment, Station 12, installed on the lunar surface on November 19, 1969, 30 kilometers from the Apollo 12 landing site. Sealed inside a ribbed aluminum housing roughly the size of a hatbox, and designed to survive the 14-day lunar night. Its purpose was straightforward: to listen, to press an instrument against the surface of the moon and characterize what was moving inside it. The science teams at the time had a reasonable expectation of what they would hear. The moon, on the prevailing geological model, was a cold and largely inert body, smaller than Earth, with a larger surface area to volume ratio, which means it radiates heat faster, which means its interior should have cooled substantially over the 4 billion years since its formation. The expectation was quietness, maybe shallow seismicity from meteorite impacts, maybe a faint tidal signal from Earth's gravitational pull at the surface. The expectation was that the instrument would confirm what the models said: the moon is geologically dead, or close to it. That expectation did not survive contact with the data. Over the following 3 years, 3 additional seismic stations were installed on the lunar surface. Apollo 14 placed a station at Fra Mauro, northwest of the Apollo 12 site. Apollo 15 placed one in the Hadley Apennine region at the base of the Apennine mountain range. The first time instruments had been placed in the lunar highlands. Apollo 16 added a 4th station at Decode. 4 stations spread across the near side of the moon, each transmitting continuously back to Earth. Together they formed the Apollo Lunar Surface Experiments Package Seismic Network, ALSEP. It ran from 1969 to 1977. 8 years, continuous, 24 hours a day, thousands of seismic events cataloged, a data set unlike anything that had existed before, and unlike anything that has existed since. Among those events, a specific category stood apart. Not the shallow moonquakes near the surface, not the meteorite impacts. Those were expected, and they looked like meteorite impacts. Something else. Events originating from deep inside the lunar body at depths between 700 and 1100 kilometers below the surface. In a body the size of the moon, geologically cold, thermally quiet, seismic events at that depth are not expected by any standard model of planetary interiors. They should not, on the prevailing account of the moon's thermal state, exist. They exist. The data is in the record. Dr. Yoshio Nakamura was a geophysicist at the University of Texas at Austin and the primary scientific analyst of the ALSEP Seismic Archive over several decades. His published work on what became known as deep moonquakes is the foundational reference in the field. In a series of papers from the late 1970s through 2005, Nakamura cataloged the deep moonquake events systematically and identified something that the prevailing explanation for them, tidal stress from Earth's gravitational field, had significant difficulty accounting for. The deep moonquakes were not random. They were not distributed diffusely through the lunar interior, the way you would expect from a body flexing uniformly under gravitational loading. They were organized. Nakamura's catalog identified more than 300 discrete source zones, fixed geographic points in the lunar interior, each one activating repeatedly over the 8-year observation period, each one producing seismic signals that looked, across multiple years of data, almost identical to one another. The terminology in the literature is nests. Each source zone is a nest. Each nest sits at a specific location at a specific depth, and when it activates, it produces a signal whose waveform is highly similar to every previous signal from that same nest. Same zone, same depth, same waveform shape. Activating again and again at intervals that correlate with the 27-day tidal cycle as the moon moves through its orbit around Earth. That is what the ALCESP data contains. The numbers are in the published record. More than 300 nests, 700 to 1100 kilometers deep, repeating waveforms, tidal periodicity. The ALCESP network was shut down on September 30, 1977. The official reason was budget constraints. NASA's funding had declined substantially after the Apollo program ended in 1972, and the cost of maintaining the stations and processing the data was deemed in the budget environment of the late 1970s prohibitive. The stations were switched off by remote command. The data stream stopped. No lunar seismic network has operated since. Nakamura's catalog, More than 300 source zones, each documented, each active, each producing repeating signals from 700 to 1100 kilometers below the surface, sits in the published scientific literature. The catalog is publicly available. The source zones are in it. The follow-up investigation that would characterize what those zones actually are, using modern seismic instrumentation at the sensitivity levels now standard in terrestrial geophysics, has not been conducted. That investigation would require a seismic network on the lunar surface. No agency has deployed one. I want to be specific about the anomaly because the specifics are what give it weight. The seismic signals from a given nest are nearly identical to one another across years of data. When the same nest activates multiple times over an 8-year observation window, the waveform of each event is similar enough to previous events from that nest that the signals can be matched by cross-correlation, a standard technique for identifying repeating seismic sources. Same location, same depth, same waveform repeated across years. On Earth, that kind of waveform consistency is associated with specific fault structures activating repeatedly under consistent stress conditions. It is not associated with a body that is supposed to be cold, rigid, and seismically dead. The Moon, in the standard thermal model, should be approaching the kind of interior temperature at which this kind of organized, repeating, spatially fixed seismicity should not be occurring. The correlation between tidal phase and deep moonquake activity is real and documented. Nakamura's work established it. It is in the literature, but the correlation is imperfect in specific ways that are also in the literature. Some nests are active during periods of relatively low tidal stress. Some nests remain silent during periods of high tidal stress. The activation of individual nests does not map cleanly onto the tidal stress cycle, and the tidal model does not predict the spatial organization of the sources. It does not explain why the seismicity should be concentrated in more than 300 discrete fixed zones rather than distributed more broadly through the interior material experiencing tidal stress. Something about the internal structure of the Moon is producing organized, localized, repeating seismic behavior at these depths. What that something is has not been definitively identified. In 2005, Nakamura published an analysis of deep moonquakes on the far side of the Moon in the Journal of Geophysical Research, Far Side Deep Moonquakes and Deep Interior of the Moon. The paper discusses the incomplete characterization the ALCP data permits. The network's geometry was never ideal for deep interior imaging confined to the near side, unable to permit the seismic tomography that would map the interior in 3 dimensions. What the data established is that organized deep seismicity exists, that it comes from more than 300 fixed interior locations, and that the model explaining it is partial. The archive ends in September 1977. No modern network has extended it. Now I want to tell you about May 1969. 4 months before the first moon landing, a mission called Apollo 10. The crew was Thomas Stafford, John Young, and Eugene Cernan. Stafford was the commander, a veteran of Gemini 6 and 9. Young had flown Gemini 3 and 10 and would later command Apollo 16. Cernan had flown Gemini 9 alongside Stafford and would later command Apollo 17, would become in December 1972 the last human to walk on the surface of the Moon. Between the 3 of them, they had accumulated thousands of hours in military and test aircraft. They were among the most experienced aviators NASA had. Their mission was to fly to the Moon and run a full dress rehearsal for the Apollo 11 landing. They would descend in the lunar module to within 15 kilometers of the surface, test the systems, and return to the command module without landing. They did all of this. The mission was successful by every metric it was designed to test. And then, on the return leg, before they began the ascent back to dock with the command module, they did something that would not be discussed publicly for 40 years. They went around the far side of the Moon. Earth is blocked. The Moon's body stands between the spacecraft and every ground station on the planet. Radio signals cannot reach it. Communication is impossible. Mission control cannot hear the crew. The crew cannot hear mission control. The only recording that continues during a far side pass is the mission recorder aboard the spacecraft itself. The Apollo 10 mission recorder continued running. What it captured is now on NASA's website. The transcripts were classified for 40 years. In 2008, NASA declassified them. You can read them. They are there. The transcripts record the crew hearing something, an unidentified sound. Eugene Cernan's words, as transcribed from the recording, "That music is really weird." Stafford responds. The crew discuss the sound, its character, its origin. They are uncertain about what they are hearing. What the transcript then records, explicitly in the words of the crew themselves, is a discussion about whether to report the phenomenon to mission control when they re-establish contact with Earth. That discussion is in the transcript. 3 astronauts on the far side of the moon, out of contact with Earth, debating whether to tell anyone about what they are hearing. The debate itself, the fact of the deliberation, is in the document. NASA declassified it in 2008 and posted it. You can read the exchange. The official explanation NASA has offered for what the Apollo 10 crew heard is radio frequency interference. Specifically, interference between the VHF radio systems of the 2 spacecraft operating in proximity. When 2 radio systems operate on adjacent frequencies in an enclosed environment, interference patterns can produce auditory artifacts. This is a known mechanism. The explanation is technically coherent. What it does not account for is the response of the crew. These were not civilians encountering spacecraft systems for the first time. VHF radio interference is not an exotic phenomenon in aviation. Experienced aviators encounter it, recognize it, and note it in the log. They do not typically find it unusual enough to deliberate about whether to report it. What the transcript records is a crew uncertain enough about the nature and origin of what they were hearing that they debated out loud on the record whether to tell mission control. The word weird appears in the transcript. The deliberation is in the document. That response does not fit comfortably with 3 experienced pilots encountering a familiar audio artifact. Those transcripts were classified in 1969. They were declassified in 2008. In the 40 years between those 2 dates, none of the 3 crew members gave a detailed public account of what they had heard on the far side of the moon during that pass. Each of them gave many interviews during that period about the Apollo program, about their experiences in space, about the moon. The specific question of what was recorded in those transcripts, in those minutes on the far side, does not appear to have produced a substantive public response from any of the 3 during the classification period. NASA's official explanation for the sound was offered in 2008, when the transcripts were released. The VHF interference account has been the official position since. The transcripts are public. The explanation is there, alongside them. What is not there is any published analysis from NASA of why 3 pilots with extensive aviation and spaceflight experience found a recognized radio artifact unusual enough to deliberate over reporting. The gap between that explanation and that crew response, in their own documented words, has not been addressed in any public communication from NASA in the 17 years since the transcripts were released. Eugene Cernan died on January 16, 2017. He was the last human to have stood on the surface of the moon. He gave hundreds of interviews in the decades between Apollo 17 and his death. The question of what he heard on the far side during Apollo 10 does not appear in any transcript or recording available in the public record to have received from him a detailed answer. The transcripts are 48 years old. The far side of the moon is where the crew was when they heard what they heard. That is in the document. What they heard has not been explained in a way that accounts for their own response to it. In 1970, a year after the first moon landing, 2 scientists affiliated with the Soviet Academy of Sciences published a paper in a state science journal. Their names were Mikhail Vasin and Alexander Sherbakov. The journal was a Soviet state publication. The paper's title, in translation, was, "Is the Moon the Creation of Alien Intelligence?" That title sounds disreputable. The paper is not a tabloid piece. It was published in a Soviet state scientific journal with institutional review. Vasin and Sherbakov were working scientists with institutional affiliations in the USSR's Academy of Sciences. Their argument was not speculation. It was anchored in data. Specifically, in the same seismic data NASA had published from the Apollo missions, the anomalous reverberations, the long-duration seismic responses to impact events that no solid rocky body model adequately explained. The seismic behavior that led them to propose a hypothesis that the data was more consistent with a hollow metallic shell than with a solid geological body. This hypothesis was not unique to them. It had been discussed informally in Western scientific literature, following the Apollo 12 seismic experiment. When the mission's intentional impact test produced a reverberation that NASA's own report described, in the technical literature, as ringing like a bell. What Vassin and Sherbakov did was formalize that argument in a peer-reviewed publication, with institutional backing based on the published seismic record from NASA's own missions. The paper was not formally refuted in the Western scientific literature. NASA did not publish a counter-analysis addressing its specific claims. The seismic data Vassin and Sherbakov cited was real. The anomaly they pointed to, a seismic response pattern inconsistent with a solid body, was documented in the record. The argument was not engaged on its scientific merits in any published Western response. The Soviet lunar program had, by 1969, achieved substantial technical success. Luna 9 made the first soft landing on the Moon in February 1966. Luna 10 achieved the first lunar orbit in April 1966. Alexei Leonov, who had performed the first spacewalk in 1965, had been designated as the planned commander of the Soviet crewed lunar mission. Following Apollo 11 in July 1969, the Soviet crewed lunar program was canceled. The official explanation was technical failure. The N-1 rocket, the Soviet equivalent of the Saturn V, failed on 4 consecutive launch attempts between 1969 and 1972. Those failures were real. The rocket exploded. The program lost years and substantial resources. The Luna unmanned program continued until 1976. Luna 24, in August 1976, was the last Soviet spacecraft to land on the Moon. Then the program stopped. The N-1 failures account for why the crewed program could not proceed on its original schedule. They are a less sufficient explanation for why no version of the program was revived in the years that followed. As Soviet space technology continued advancing in other areas, long-duration orbital stations, continuing planetary probes, crewed Earth orbit missions through the 1980s, the technical capability improved, the lunar program did not resume. Alexei Leonov gave an interview in 1999, documented, attributed, on record, in which he stated that the Soviet program's cancellation was connected to, in his phrasing, what they knew by then about the Moon's nature. The statement is there. Leonov did not elaborate on it in that interview. He did not specify what was known, when it became known, or how it factored into the program's trajectory. He is not alive to be asked to clarify. He died in October 2019. The statement sits in the record alongside the absence of elaboration. The Soviet Union had every geopolitical incentive during the years of the Cold War space race to find anomalies in NASA's lunar data and publicize them. They had independent instrumentation. They had independent scientists. They had every institutional capacity to investigate the same seismic data NASA had published and to produce an alternative analysis that served their strategic interests. Their scientists did produce such an analysis. In 1970, in a state-sanctioned journal, the analysis pointed to the same anomaly NASA had documented, a seismic signature inconsistent with a solid rocky body. Their scientists published it. NASA did not respond to it. The Western scientific literature did not formally refute it. And then the Soviet program also stopped. 2 programs, opposing governments, no coordination, the same object investigated from opposite sides of the Cold War, with independent instruments, by scientists with strong institutional incentives to find and exploit each other's anomalies. Both programs encountered the same seismic data. Both programs ended without returning a human to the surface. The alignment of those outcomes, from opposite sides of the space race, is the anomaly the tidal stress model does not address. The space race ended. The Moon did not. The standard scientific explanation for the deep moonquakes begins with tidal mechanics, and I want to state it as clearly and fairly as it deserves to be stated. Because the explanation is real and it accounts for a significant portion of what the data shows. The Moon is gravitationally locked to Earth. Tidally locked, which is why we always see the same face. As the Moon moves through its elliptical orbit, the variation in distance from Earth causes a corresponding variation in the tidal stress exerted on the lunar body. At perigee, the closest point, the tidal force is stronger. At apogee, the most distant, it is weaker. This cycling of stress through the lunar body approximately every 27 days is real. It measurably deforms the moon's shape by a small amount, and it is correlated, in Nakamura's analysis of the ALSEP data, with the timing of deep moonquake events. Many nests activate at predictable tidal phases. The correlation is statistically significant. The tidal model is not wrong. It is an explanation that accounts for something real in the data. What it does not fully account for are three specific features of the deep moonquake record, each acknowledged as unresolved in the published geophysical literature. The first is the depth. At 700 to 1100 kilometers below the surface, the standard thermal model predicts material cold enough and rigid enough that the observed seismicity should not be occurring through any process the tidal model describes. Whether tidal stresses are large enough, in material at those modeled temperatures, to produce what the ALSEP network recorded is a question the literature has not cleanly resolved. The second is the spatial organization. The tidal model predicts stress distributed through the lunar body and released where material is weakest. It does not predict that more than 300 specific fixed points in the deep interior should be producing organized, repeating seismicity with waveform consistency across years of data. That degree of localization requires an explanation of interior structure at those depths. What is at those locations, why they, and not others, that the tidal model does not provide. The third is the activation inconsistency. Some nests activate at low tidal stress. Some do not activate at high stress. The correlation is real but imperfect, in ways the model does not predict, and the mechanism controlling which nests activate when beyond the gross tidal schedule has not been identified. The investigation that would resolve all three is the same investigation: a modern seismic network on the lunar surface, current generation sensors, multiple sites across nearside and farside, operating long enough to build a catalog exceeding the ALSEP archive, permitting the deep seismic tomography that would image the interior at the relevant depths. That investigation has not been conducted. The technology has existed for decades. I want to be precise about where I am landing, because this subject is one where imprecision is a form of dishonesty. I am not telling you that the signals in the ALSEP archive are artificial transmissions. I am not telling you that the moon's interior contains any kind of technology. I am not telling you that the moon landing was faked. That is a separate argument. It is not an argument I am making, and conflating it with the anomalies in the seismic record would obscure the genuine scientific questions in that record. What I am telling you is that NASA's own published seismic data documents repeating signals from more than 300 fixed points in the lunar deep interior, at depths inconsistent with a thermally inert body, on a tidal schedule that the tidal model does not fully predict, with waveform consistency that is not explained by any published account of the lunar interior. That anomaly is in the published literature, cataloged by Nakamura and others, referenced in geophysical papers through the present. It is not fringe material. It is the official published record of 8 years of continuous seismic monitoring, the only such record ever produced for the moon. What I am also telling you is that the Apollo 10 crew recorded an unidentified sound on the far side of the moon in May 1969. 3 experienced pilots found it unusual enough to deliberate explicitly on whether to report it. The transcripts of that deliberation were classified for 40 years. The official explanation for what they heard does not account for the crew's own documented response. Eugene Cernan is dead. His elaboration has not come. The transcripts are public. The explanation alongside them is partial. The ALSEP Seismic Archive is held at the Lunar and Planetary Institute. Nakamura's catalog is published, more than 300 source zones, 700 to 1100 kilometers deep. Repeating waveforms, a tidal schedule the model does not fully predict. The catalog has been in the literature since the late 1970s. The last data in that archive was recorded on September 30th, 1977. No seismic station has operated on the lunar surface since. No human has stood on the moon since December 1972. No mission has been designed to place a modern seismic network on the lunar surface and conduct the deep interior survey that the ALSEP data identified as necessary. The source zones in Nakamura's catalog, each one a specific fixed point in the lunar interior, each producing repeating signals from depths the standard model does not cleanly account for, have not been investigated at any resolution better than what 1969 era instruments permitted. Those source zones are in the published record. They have been there since 1978. The question of what they are, what produces them, why those specific points at those specific depths with that specific regularity, that question is in the record alongside them. It has not been answered. The investigation that would answer it has not been conducted. The network that would conduct it has not been built. I find that difficult to explain,